need to take a transformer down. The second transformer that's remaining is capable of supporting both halves of the board. When you look at this, although physically right now it looks like a single board, there is actually two 3,000 amp buses, one on this side, one on that side, and if you look at your single line, they will be two small little lines with a breaker in the middle. That breaker in the middle is called a tie breaker. It remains normally open. So the way that this system operates normally is transformer TX1 feeds board number 1, transformer TX2 feeds board number 2, and they both sub-feed separately. In the event that you remove, or lose the transformer, you can close the tie breaker, which physically ties the two boards together, and the loads that were fed from transformer 1 that was down are now sub-fed with the two boards connected from transformer number 1. If you lose both transformers, I mean, that's a catastrophic failure. You have bigger issues than worrying about feeding loads in the building. So each of the boards, all of these breakers on here, you've got a main breaker for board number 1, a main breaker for board number 2, which is all of the breakers. You have a tie breaker in the middle, and the rest of the breakers are sub-feeds. One feeds the east riser, one feeds the west riser, and then the other ones feed some other stuff. There's a feed, a normal power feed to the transfer switch, which goes all the way up to the roof, feeds the emergency distribution while normal power is in place, which is this guy, and then there's some other sub feeds. There's a distribution board down here. Yeah, so the distribution in the building, you'll notice there's different ways of feeding boards. You'll notice the high voltage primary cable, which is the red stuff, is tech cable. You'll notice pipe work coming out of the back, which is wire and conduit. And then you'll notice these two runs right here, which is a bus duct system. These bus ducts run out of the main board, each from their own breaker, and up the riser east and up the riser west. From each one of those bus ducts, we tap off of those bus ducts, and we feed a 600 volt distribution board similar to one of these. Each one of those distribution boards will feed a 347 600 volt lighting panel and miscellaneous 347 600 volt loads on the floor. They will also feed a large 225 kVA step-down transformer, which feeds another distribution board at 120 volts. That 120 volt distribution board, or 208 volt distribution board, feeds sub-panels throughout the floor. That's the distribution in the building in a nutshell. That's all of the sub-paneling and all of the transformers that you see on the normal power single line drawing. And that is what the two bus ducts currently feed. In terms of why we use different cabling, Scott can explain what the benefits of using one or the other are.
Yeah, so we'll use different methods depending on the install. If you look at this center board here, there's got to be half a dozen or a dozen breakers in there. You will see a limited amount actually coming out of the top. There's likely quite a few feeders out of the bottom of this board, so we'll be in here during the initial construction before they're actually pouring this raft slab. We'll be putting in that ground grid that Raymond talked about. We'll be putting in conduit runs essentially in the concrete for a couple of reasons, because it can be PVC conduit, which is cheaper, and it's actually a lot faster in terms of labor. So we'll be working with the manufacturers and the engineers to make sure we get these shop drawings, months and months in advance before the stuff ever shows up on site. Essentially, once the structure starts coming to life on a building, we're in here, we're flying this gear down here with the tower crane, and essentially the room gets built around it. So,
when we constructed this room, and similar fashion to the way that we're doing the new Schulich expansion, all of this gear goes in here before the building is anywhere close to complete, before the roof slab, in this case the main floor slab is put on. All of this gear arrives and it gets put in place. It doesn't necessarily get all hooked up, but the room is built around the gear. This isn't the type of gear where you just float it in the front door and you haul it down the stairs. It's actually put in place when the room is constructed before the floor slab comes on. In the Schulich building, this building's a little bit nicer because it was a completely brand new building. So you can size doorways, you can size hallways, you can size stairwells in order to maneuver some of the gear. In the Schulich building, where the existing high voltage sections, which is identical to this, we have the same type of system over there. It's already an existing building. The sub-basement level in that building is less than half of the height of this ceiling. So moving this type of gear in and around that type of facility, you can't do. So what we've got in the new loading dock area, which sits just on the northwest side of C block, there's a large transformer room. Similar to this, a large transformer room, transformers are the same, high voltage gear is the same. Because we were dealing with an existing facility, we actually have our 2 transformers and our high voltage gear in one room, and they feed the 600 volt distribution board, which in that building is significantly bigger than this physically, just because there's far more feeder breakers, sits in another room. The room with the transformers and the primary gear has a lift-out well roof, come with a crane, and it's a big concrete block. You pull the concrete block off with a crane, and you can crane the equipment down into the room. Again, even though the Schulich expansion is still, the loading dock is there, and they're just starting on the main slab of the infill, all of the electrical gear for that building, and subsequently all of the electrical gear going into that building is sized large enough in order to feed the entire engineering complex, is already in place. It's not hooked up physically, wired into the ring main yet, but all of the equipment is in there, and they are building the building essentially around the electrical equipment on the lower floors.
Yeah, so